All right, ladies and gentlemen. Happy Tuesday. Nice to see you. Couple of items to know. Brandon, sit. I have your test. I put it in the grade book. So at some point you can check it. Don't go check it now because I'm not at that point. Some of you did very well, and some of you were lucky to get your name right. And so it was worth 48 points, but I put it in as a scale factor of 0.5. Yes, you need to still make it up with me. It's your responsibility. Come see me. Come to my office. What period is he off? Perfect. First period, you know where my office is. When are you off? You have a few days, extra days to do it. So what periods would you be off? Come see me before school then, please. My office. And then you still have OMIA too, right?
Yeah, I'm off Thursday. Can I just come in after this class?
Yeah. Let's not do it today though, because I don't have it with me. Can we do it tomorrow? Cool. Thank you. Anyone else? I think that's all. Perfect. So I kind of went back and I was reflecting on a little bit about how we did the first. It was almost 9 or 10 homework assignments, including the 2 reviews. And I think some of you are really scared to ask for clarification. And I apologize if I seem like this mean, angry person that won't ever help a kid. I don't think I am that way. But some of you are really frightened to ask for help. Or, hey, could you explain that a different way? And, you know, a lot of these concepts are new. So some of you that are like, oh, sweet, I saw this in 8th grade. Now you're in stuff that you haven't seen in 8th grade. Or, you know, whatever grade you had seen it in. So be sure that you're asking for clarification. Now, before we walk through and talk about the homework, you need to make sure a couple things. I want to go back through and I want to show you on the graphing calculator, not that I want you knowledgeable of how to do this on a graphing calculator, I want you to see what the graph's doing so you can have some clarification of what's actually happening with the problem. So make sure phones are away, make sure earbuds are out of ears, and I will let me hand out what the notes will be for today. Then, so there's a big old space on the back that you could do some clarification notes. Is that okay? Yeah. Does that make sense? And again, I'm showing you showing you something on the graphic calculator, not because I want you to be awesome at using that for this feature. I want you to see this and we can discover it together. That way, you have a pretty good knowledge. So there's note sheet coming out to you, the front and back. And I want you to go to the back side because that's where we're going to do our clarification notes. But don't write everything down that I'm trying to say. I will tell you what to write down once we discover a few things. Okay? All right, and I'm going to go to a later page on the notes. Okay, so item 1, and this is just kind of what we talked about yesterday. Item number 1, this is an exponential function in its basic form. Now, I'm going to put this there because that's going to come into play, and it actually came into play on last night's homework. Okay? Is everyone okay so far? And there's really nothing you have to write down right now. You're just paying attention to what we're doing. So if this is missing, if I have this as an equation, if that's not there, what technically is my C value, logically? Nothing, which is 0. So if I just have this, my C value then is this. Okay? Which means on my xy axis, we have something that is called an asymptote, and the asymptote is the line that we can't cross. So if we have just a times b raised to the x, my asymptote, the line that I can't cross, is the x-axis. Okay? As that C value changes, and again, I'm not worried about what A and B are, but let's say I saw like a +6, that means that I go, and this becomes my asymptote now. Okay, and again, the asymptote is this imaginary line that doesn't really exist, but our graph can't cross it. Okay, it can come real close to it, but it can't cross it. So, what do you think would happen if I had this equation? What do you think my asymptote would be? -2? Does that logically make sense? And again, that asymptote is an imaginary line. It's called the horizontal asymptote. It's an imaginary line that you cannot cross over. You can approach it from the top or the bottom, but you can't cross it, no matter how far out you go. So just so you feel safe with this, horizontal asymptote, horizontal asymptote, horizontal asymptote. Now, if you want to write down some notes on that little thing, just jot down a little bit of stuff. I think that's a relatively simple concept that's real easy to get hung up on. Agree? So again, horizontal asymptote, it exists as a line that's not drawn as part of the graph, but it's a horizontal line that I can't cross over. Okay, I can come real close to, but I can't cross over. So that's the first part of our information. Yeah. Nope, you good? Okay, so that's a real basic foundation. There's nothing that needs to be thought of way hard. It doesn't matter what the A and the B are. If that is forming an exponential function, and then if there's nothing else there, your x-axis is your horizontal asymptote. If I'm adding to it, the horizontal asymptote moves up. If I'm subtracting, the horizontal asymptote moves down. Can I move off this slide? Does anybody need more time? Good? All right, so now, the next thing I wanted to talk about, and we're going to use the graphing calculator, is how does, if I had this as my basic function, and then let's start putting things together. So, I'm going to actually erase this right here. So, let me ask you this. As that sits there right now, what is my C value that's not there? 0. Does everyone feel comfortable saying that? So if I wanted to list what my C value is, it's technically +0. Now, be careful on this answer. Now let me preface this before we go there. If I say 0 times something, what is always the answer? 0, right? 0 times something is always 0. If 0 is my exponent, my something becomes 1. My base becomes 1. Okay? So, what do you feel my A value is right there? Careful. Don't say 0 because it's not. If it was 0, that 3 to the x would be gone. So, it's 1. So, that's 1 times 3 raised to the x. Okay? So, that's just kind of the nuts and bolts right now. Yeah?
The B equals 3?
The B is 3, absolutely. Yeah. Huh? Because my B is raised to the exponent, so that's raised to the exponent.
No, I'm saying, are you going off of a problem or are you making it up?
Just making it up off the cuff. Okay? So, now with that known, I want to take a look at what this equation looks like when I graph it. Okay? So, again, I'm going to use the graphing calculator. And again, you don't need to be following along, but I have y equals 3 to the x. So y equals 3 raised to the x power. Okay? I need to turn my plots off. I need to turn that off up there. So I'm going to hit enter. And then I'm going to go zoom 6. So that's what my graph looks like. And again, guys and girls, I don't need you to know how to do that on your calculator. I just want you to visualize it. So does this graph mimic what you would think would happen as far as the horizontal asymptote? Okay, we go back to our original problem. What is our C value? 0. Where does it appear this is not crossing? At 0. Does that make sense? So this line is going forever this way, getting closer and closer and closer to the horizontal line, y equals 0. Y equals 0 is a horizontal line, right? But it'll never cross it. So what are a few other characteristics that you can kind of look at on this graph that might stick out to you a little bit? Do you think it would be a growth problem? Yeah. And I said growth yesterday because as you go to the right, our graph is now going away from the x-axis. Agree? So definition of growth is, as I go to the right, graph is going away from the x-axis. Okay? So growth could go down like this as well, and we'll take a look at that as well. So as I go to the right, this graph is going away from the x-axis. So this is an exponential growth problem. Okay? So it's growth. So let me go back and let's just write that down. That this problem, this is growth. Okay? Anything else that sticks out? And maybe you could do this, and this might make a little bit more sense. So I'm going to use my tools of my trade, see if I can figure this out. Let's just kind of zoom in on our graph a little bit. That's as far as I can get. Okay? Can you still visualize the graph? Obviously, it's right in your face right up there, right? Where does this graph, as a point, cross the y-axis? Remember, that's the vertical line. 0, 1. Does everyone feel comfortable with how we just said that? So it crosses the y-axis right here at this point, 0, 1. Is that okay? Okay, so let me escape out of here. So I'm going to hit my escape. So that takes us back. Okay? So let's go to our thing. We're going to just write that this crosses the y-axis at 0, 1. Now let's verify why that is true. Okay? If I were to take this 0 right here, that indicates it's crossing the y-axis. If I take that 0 and plug it in, what is this, an x or a y value? X. So if I plug 0 right in here, I get 3 raised to the 0 power. And 3 raised to the 0 power is 1. That's why this works. Okay? Okay, hang on. We're not done. I will get there. Does everyone feel comfortable with how I just stated that? Okay, so let's walk through it one more time. Here's my basic function. If I wanted to figure out where it crosses the y-axis, I take 0 and I plug it in for my exponent. And then I get 3 raised to the 0 power. So 3 raised to the 0 power is equal to 1. That's why that comes out to be 1. Have it right so far?
Yeah.
Feel good?
Wait, so do you use the y equals 3x plus 0 do you put that in the...
I don't, so this was just verifying that why we had the horizontal asymptote at 0. This is just to indicate we have a lead coefficient of 1, but we don't really need it. So we're just focusing on this problem right here. This is my parent function. We just kind of modified this to show where all of our characteristics came from on this graph. Okay, now, you remember yesterday, we did a t-table and we went -2, -1, 0, 1, and 2. Still with me on that?
Yeah.
I want to step away from that. Okay? So right now, does everyone feel comfortable that on our graph, we have this point? Does that seem good? Anything about that that's goofy? So that should be matching up kind of with our, what's on the graphing calculator. Now, I want to see if we can't discover this. Let's see if we might maybe find a pattern. So I'm going to go back to the graph, I'm going to zoom in on it again. I'm going to zoom in on my graph again. Let's see, zoom. So 0, 1 right here. Let's take a look. 1. Right one up 1.
You made this
There.
one too.
And then if I go right 1, 1, 2, 3. Okay.
You made this one up also.
Yeah, this is the same problem we're working on. We're just trying to build off of it. Okay, let me escape out of this. Okay, so what I want to do is I want to take a look at a table on our graph. And our table will allow us to see certain points. So I'm going to go second table. So we agree with 0, 1. Yes? And I could go backwards on this table and negative if I wanted to, but I'm not worried about it. But then this goes to 1, 3. So will you write that point down for me in parentheses? 1. So you have the point 1, 0, and then right below it, write 1, 3. Now these are a whole bunch of other points, but I'm not worried about those. I'm just worried about the next point. 1, 3. Okay? You have 1, 3 written down? So if we go back to our thing, we go to 1, whoops. We go to 1, 3. Take a look. Can you see how I would get to 1, 3 by plugging this x value into our original?
Yeah.
Because 3 to the first power is 3. So this is all you need. You have this point where it crosses the y-axis, and then another point right on over. And this is what our graph looks like. Okay, so take a couple minutes, about 90 seconds, write down what you need to off this page. And let's see if we can build upon this a little bit, okay? And if it's okay with y'all, I'm going to stick with, as my parent function, y equals 3 to the x, but we're going to start modifying a few things. Is that okay? So we're going to modify a few things, but we're going to stay with y equals 3 to the x. Give that another 60 seconds to write down what you need. Does anybody need more time to write anything down? Okay, I want to modify this. So we're staying with the same function. I'm going to make it like this. So I'm going to stick with y equals 3 to the x, but I'm going to do a few things to this. I'm going to go plus 2, and I'm going to have this times, let's not use that exactly like that. Let's go with, so does everyone see our base function that's still in there, y equals 3 to the x? Now we're going to multiply that times 4, and we're also going to plus 2. So does everyone feel okay? And again, I'm just making this problem up off the cuff. So what would my horizontal asymptote be? Okay, so it's the line y equals 2. Bless you. So we have something like this right now. Okay, that's this, and that takes place because of that. Is that okay so far? Okay, now, from our old graph, we knew we had 0, 1. This is from our old information. And we had 1, what was the other point? 1, 3. So let's go ahead and plot these. So 0, 1 was here, and then 1, 3 was here. So this right here is my parent function. That was what my original graph looked like, right? Maybe we put a little note. This is the original. Okay? Does that make sense? Have I graphed anything on the new modified graph yet, other than the asymptote? Have I graphed anything other than the horizontal asymptote? Okay, so let's see if we can kind of logically picture this, what's happening. So, if I wanted to find, so this is my new information. If I wanted to find where it crosses the y-axis, that's the vertical right here, right? I'm going to plug 0 in. Okay, now let's be careful. Now, on our old one, if we plug 0 in, we got 3 to the 0, which was 1. But let's see what happens here. If I take 0 and plug it in here, I get 3 to the 0, which is 1 times 4. 4 plus 2. So now, let me just erase this right here because my graph got a little taller. Okay, going up to 6. So 1, 2, 3, 4, 5, 6. Okay? Now, let me go to my graphing calculator, and I just want to verify 2 things. 1, do we feel comfortable with the horizontal asymptote being there? And 2, do I feel comfortable with the point 0, 6 being where it crosses? Yeah.
Why would it be for the horizontal asymptote then? Why wouldn't it be 4? Like what
Because this will indicate the asymptote. Whatever I'm adding or subtracting from the exponential function part.
Oh, okay.
Okay, yeah. Okay, let's walk back through the 6. Okay, I'm going to do, so you agree with our original function. When I plugged 0 in to 3 to the x, I got 1, right? So this became 1. So 4 times 1 is 4. 4 added to 2 is 6. Okay, now all I want to do is, I'm not too worried about the graph. I just want to verify, 1, do we feel comfortable with this? And 2, do we feel comfortable with this? So let's take a look at our graphing calculator. So it's y equals 4 times 3 to the x. So I'm going to go down here. I'm going to go y equals 4 times 3 raised to the x. And then I added what to it? I'm sorry? 2. And the 2 is what tells me my horizontal asymptote, right? And then the 0, 6 is what I got because I plugged 0 in for my exponent. So I got 3 to the 0, which was 1. And then 1 times 4, which is 4. 4 added to 2 is 6. Okay, so this is good. Both graphs will be graphed. I'll have the blue as the original. The red will be the new. Okay, so what did we say the horizontal asymptote would be? 2. Does this appear this is at 2? Okay, and then what did we say that the where it crossed the y-axis would be? 6. So it's 0, 1, 2, 3, 4, 5, 6. And let me zoom in on that so you can see that it does verify.
So the horizontal asymptote means that if it never curved, it would go directly over the
Do, right? So that's where this is. That's where your plus 2 is taking place. So it shifted the whole graph up 2. So we added 2. And then, do you agree that this is 6? 0, 1, 2, 3, 4, 5, 6. Yeah. Does that make sense? Now remember on our graph we had one other point we plotted, right? One other point we plotted. So with one other point plotted, this is all we did. To find that second point, I'm going to plug in 1. 1 comma something. Now let's see what happens here. If I take 1 and plug it into x, 3 raised to the first power is how much? 3. So 3 to the first is 3. 3 times 4 is 12. 12 added to 2 is 14. So 1 comma 14. So 1 comma 14. We're way up here, right? So this is what this graph's doing. Okay? Like I'm 1 comma 14 is actually off our graph, right? It's actually higher up here. So let's look at our calculator on the table to see on this graph, on the table, do we have the point 1 for an x, 14 for a y? Okay, so I'm going to go to second table. So remember the blue was our first line. Our second, this red, so do I have the point 1 comma 14? You see how I just did that? So I want us to get away from the -2, -1, 0, 1, 2, and realize all I have to worry about is plugging 0 in. If I plug 0 in, that finds where we cross the y-axis. And if I plug 1 in, that gets me the second point. If I'm adding or subtracting something to my thing, so if I have my c value, the plus or minus out there, that moves our horizontal asymptote up and down. Okay? So, does that clear about 30% of your confusion up? Okay? And that's all I'm aiming for, about 30%. Okay. Next, I would like to take a look at our homework. Okay, so if you would, get that out. Now, I need you to do me a deal. I need a deal from you. So what I'll do is, why don't I read through the quick answers real fast, and we'll see how we do, okay? So problems 1, 2, and 3 have the exact same directions. Everyone with me on page 25, right? Okay, it says determine if the equation represents an exponential function and explain. So problem number 1 is y equals 9x. Exponential? No, it's linear. Okay? X is not an exponential function because you just have a base. So that's like saying y equals mx plus b where it crosses the y-axis at 0. Problem number 2, is it exponential? Yes. How do you know? It has an exponent which is a variable. Does that make sense? It just means that we're still multiplying. We're going 2 quantity. So it's like me going 2 times 3 raised to the x. Same thing. Okay? Problem number 3. Exponential or not? Yes, it's exponential because I'm being raised to an exponent, which is a variable. A variable is a letter. Okay? So if you had a problem that was like y equals 3 squared, yeah, you have an exponent of 2. That 2 is not a variable. So you want your exponential function, you want your variable, your unknown, your x value to be the exponent. Okay? Clear as dirt on 1, 2, 3. All right, problem number 4 and 5. So determine if it's linear or exponential. So what you have to do to determine if it's linear or exponential is you look at the y component. So we're growing the same in the x direction, 1, 2, 3, 4. Agree? Both lines are going 1, 2, 3, 4 in the x direction. Yes? So if you look at the y component on number 4, it goes from 3 to 9, 9 to 27, 27 to 81. So it's growing fast, isn't it? So that's got to be exponential. But if I look at number 5, it still grows 1, 2, 3, 4 in the x direction, but it goes from 4 to 6, 6 to 8, 8 to 10. So I'm adding 2 each time to the y. So that's linear. So 4 and 5, 4 exponential, 5 linear. 6, some of you might have given up on 6 and 7 because you're like, dude, that's too hard. So watch this. Ready? Where do you think I want to plug -2 in? Into the x. So this wants to go here. So I have 2 times 4. Now it's raised to the -2. If I raise something to a negative exponent, it wants to flip over. how do I flip over a whole number? Turn it to a fraction. So this 4 becomes 1 over 4. And now that's raised to the second power. Does that make sense? Where did the negative go? Well, I already flipped my number over. I made it a fraction. It's no longer a negative exponent. So what does this mean right here? This means 2 times 1/4. But what's going on with 1/4? It's the second power. So you have 1/4 times 1/4. So 1 times 1 is 1. 4 times 4 is 16. So this becomes 2 times 1 over 16. And 2 times 1 over 16 is equal to 2 over 16, which is 1 over 8.
Wait, 2 over 16. How do you get that?
Yeah, how did you?
Why would?
2 over 1. 2 times 1 is 2. 1 times 16.
Oh,
Multiplying. So that's where he comes up with 2 over 16. And 2 over 16 reduces to that. Problem 7, though. Problem 7, they have it in functional notation, which is just fancy. Same thing as y. Okay. Function at x means same thing as y equals -3 times 5 raised to the x power. Where is this 3 going into? Goes into the x. So this goes into the x. So that gives me -3 times 5. 5 is to the third power. So 5 to the third power is 5 times 5 times 5. It's 125. So 3 times 125 is -375. That's my answer. Yeah.
Hold on. Where did you get the 2?
2.
Does that say 2 or?
Where on this
On the
number?
2, it says 2x equals -3 at the top, right next to the 7.
This?
Yeah.
That's function, f at.
Oh, okay.
And f at x means the same thing as y.
Okay.
It's called functional notation. Okay. So then 8, 9, and 10, they just want us to do the exponential function and graph it. So let's see if we can figure it out. Okay. Now remember, when we're doing exponential functions, if we focus on plugging 0 in for the x, we find where it crosses the y-axis. If we plug 1 in, we find a second point. Now, just by looking at 8, 9, and 10, I know there's fractions. Just looking at 8, 9, and 10, do you think that 8, 9, or 10 have a horizontal asymptote other than 0? Take a look at 8, 9, and 10. Do they all have a horizontal asymptote of 0? Does everyone understand why? I'm not adding or subtracting an extra number with those. Okay? So 8, 9, and 10. Let's see if we graph them all on the same. So, okay, we'll do number 8 as a blue. How's that sound? Number 8 will do blue. So we have function at x equals 1/2 raised to the x. Okay? Ready? Let's figure out where it crosses the y-axis. So I'm going to go 0, comma, something. So if I take 0 and plug it into 1/2, what do I get? Or if I plug 0, if I raise 1/2 to the 0 power, what do I get?
Oh wait.
1. Now, because I don't add or subtract anything, this down here is my horizontal asymptote. Okay? Now let's figure out a second point. What x value did I plug in for a second point? What x value did I plug in to get a second point? 1. I already plugged 0 in for that x. So now I'm going to plug 1 in. So what is 1/2 raised to the first power? Just 1/2. Okay, so I get 1 comma half. Okay? Would you feel comfortable to know that this graph is a decreasing function?
Yes.
So this graph kind of looks like this. What do you think made it decreasing? What made it decrease?
The 1/2.
The 1/2. You had a fraction between 0 and 1 as your base, so that took place
So wait, how do you know that it curves and it's not just a linear function?
because it was raised to an exponent. If it's raised to an exponent, they're all going to do something. Yep, they're gonna do this, they're going to do this, they're going to do this, or they're going to do this.
Okay.
All exponential functions. In an exponential function, doesn't matter what, no matter what, it'll never turn linear. Okay? All right. Problem number 9 we'll do in red. Okay? Problem number 9 we'll do in red. So I have g at x. That means the same thing as f at x, which means the exact same thing as okay? So, if it was just 1/3 to the x, it's going to look very similar to our blue line. But something sticks out that's going to change something. What extra does this have? There's the negative out front. Okay? So let's figure out where it crosses the y-axis. So what am I going to plug in to get where it crosses the y-axis? 0. So 1/3 raised to the 0 power is 1. What do you think this negative does? Makes it a negative 1. Exactly. Does everyone see why that became a negative 1? So 1/3 to the 0 is 1. I have a negative outside of that, so it makes the whole thing negative. Okay? Let's plug one more point in. We're going to plug 1 in. Still with me? We're going to plug 1 in. Okay? 1/3 to the first power is? 1/3 raised to the first power is? Just 1/3. There's a negative out front, so what's my answer going to be here? Okay? So I get 1 comma negative 1/3, which is like here. So this is those are both decreasing functions because as I go to the right, they approach the x-axis. Does that make sense how I said that? So those are both decreasing functions because as I go to the right, both of the graphs are coming very close to the x-axis. One's coming down from the top, one's coming up from the bottom. Okay? Let's do number 10 in green. Number 10 in green. So I have h at x. Okay? So, I have a half out front, agreed? What is my exponent being, what's my base of my exponent? Is it a fraction or is it a whole number? It's a whole number. Okay, so that's going to be maybe something a little bit different. So let's figure out where it crosses the y-axis. So what do I plug in to find where it crosses the x-axis or y-axis? 0. Okay, we still have this asymptote down here because there's nothing else beyond. So if I plug 0 in, 4 raised to the 0 power is 1. 1 times 1/2 is 1/2. So 0 comma half. Is that okay? Make sense? What do I plug in to find my second point? 1. So let's plug 1 in. So 4 to the first power is 4. Agree? What's half of 4? So 1 comma. So look what this one's doing. It is increasing. It's growth. We have growth on this one because as I go to the right, It's going away from the x-axis. So, few things. They also asked for the domain. The domain on all of these is negative to positive infinity. That just means I can plug negative to positive, any number I want in, and I get a number out. Is that okay? Let's think about my range on the blue. My range on the blue.
So this will be a decaying graph.
It's a decaying, so we're looking at the blue graph. Everyone identify that one okay? Okay, where is the blue graph? As I go to the right, where is the blue graph approaching? X-axis. The x-axis is y equals what? So it's approaching 0. Okay? Where did the blue one come from? Way up high. Where did it come from? Way up high in the y direction. It's positive infinity, right? Your range talks about the where are you coming from in the y direction. Okay, so the domain for the red is still going to be the same. Let's find out the range. Okay, where is the red going to? As I go right, where's it going to? As I go right, where's it going to? It's trying to approach the x-axis. The x-axis is what number? 0. Where did where did the red come from in the y direction? It came from way down low, so negative infinity. Okay? And then the green, again, our domain will still be negative positive infinity, but my range of my green, where did it come from? Hang on, don't pack up yet. Where did it come from?
0.
It came from 0 in the y direction. Where is it going in the y direction as I go this way? Okay. Ladies and gentlemen, I think with what we just covered, we have enough knowledge, just how we just did that, to finish up the rest of that page and do page 27, 28. Guys and girls, you have the knowledge to go through this and do it, okay? Take your time. Find the 2 points. I know you can do it. Have a great day, everybody. Whoop, orange things just flew all over the floor.